This is the third time we are discussing two sum problem, and in this podcast we will discuss this two pointer method, where last time when we were discussing two pointer method, it had given us that this solution only gives one this solution finds only one solution. That means only one pair max it could give. When it finds the first pair, it will just return it and exit the function. So we thought of modifying it, and just to return all the solutions. So for that, it has given us this solution where it is sorting the array first. So it is sorting the array first of all. So we will return all the indices, then it is just comparing all the values and finding its sum. If that sum is equal to target, we'll just return those values. Okay, so this solution returns the values. Skip duplicates, optional skip duplicates, but we don't want to skip duplicate, so this skips the duplicates. If left is less than right and nums of left equal to left minus 1. Okay, that means if same values are available in the array, then just to skip those values. Yeah, it does. We have to skip duplicates here because this solution, this code is returning, it is focusing on values, right? So while returning values, there is no point of returning the same values again and again, right? So that's why it is skipping duplicates as well. So I'll read the code from the first line. So we are returning an array of vectors, a vector of int to sum all pairs, and input arguments are vector int ampersand num int target. We are solving two sum problem here, and we are returning all possible values. Okay, array of values. So the result array of vectors is vector of vectors is declared. Vector of int result. Sort nums dot begin and nums dot end. So two pointers need sorted array. Yeah, this two pointers method always need a sorted array. That's why first of all it is sorting the array, then it is taking two pointers where left starts with 0 and right start with the rightmost index, that is nums of size minus 1. While loop starts while left is less than right, int sum equal to nums of left plus nums of right. If sum equal to target, then result dot push back nums of left comma nums of right. We are adding these pairs. Pairs are always given in curly brackets, and left and right are iterators. Nums of square bracket of left gives value at the left iterator in nums array. Similarly, nums of right. And here just telling you syntactically that we are using round brackets, curly brackets and square brackets all in this line. You should know the difference and the reason why we are using it. Pushback functions arguments are given in a round bracket. Pair is for a pair we use curly brackets, and for values at index in array we use square bracket. Okay, after adding this nums of left and nums of right in the result using pushback function, we increment left and decrement right. Okay, now we are adding two lines to skip the duplicates. While left is less than right, ampersand nums of left is not equal to nums of left minus 1, then left plus plus. Okay, if left is less than right, which will I think this check is not needed because we are already in a while loop where left is less than right. Okay, Let's just to clarify, ask ChatGPT, is this check needed here? Check needed here because we are already checking in above while loop the same condition. Explain whether needs left is less than right. Again, since you are already inside left, while left is less than right loop outside, yes, it is still needed inside, because inside that inner while we are doing L plus plus R minus minus. Okay, which moves L and R pointers away from their original left and right. After some steps, it's possible that L crosses R. We must stop immediately if that happens. Why exactly? Okay, we must stop immediately. This is very important line that they have highlighted, as we are moving after this left is less than right check. We are moving left and right pointers by L plus plus and R minus minus. That's why this left is less than or equal to right check is important here. Okay, this left is less than right check is important. And ampersand nums of right equal to nums of right plus 1. Okay, right is comparing with right plus 1, left is comparing with left minus 1, and if that is the case, left plus plus. If right is the case, right minus minus. Else, if sum is less than target, left plus plus. Okay, if sum is not equal to target, it is less than the target, then we go to this else if condition, where we will just increment left pointer. Otherwise, if sum is greater than target, we will go in the last else statement and we will just decrement the right pointer, and outside of this while loop we will return the result. Okay, so here we are returning the values. So in the let's discuss then the last where we used to return only single pair but with indices, with original indices. Let's discuss that two pointer approach. In that two pointer approach, we are declaring a vector of vector int result initially, then we are creating nums with index. Okay, and we are creating a different vector of pairs, and in these pairs we are we will add the value with its index. Okay, that's why its name is also nums with index, and we are storing indices because we have to return the indices, and we are handling indices very carefully in this solution. Then we will start a for loop where int I equal to 0, I is less than nums dot size I plus plus, nums with index dot pushback, nums with index dot pushback, nums of I comma I. Okay, so this nums of index vector has values nums of I comma I, value first and then the index. Okay, and these are in pairs available in the array, that's why they will be enclosed in curly braces. Okay, just one for loop. We have just declared a nums with index, then we have created a for loop from I goes to 0 to nums dot size. We will add all the values with its indices in pairs in this nums with index vector. Okay, now when we have saved all the indices, we will sort this array nums with index dot begin comma nums with index dot end. Okay, this is the syntax for sort function, nums with index dot begin, nums with index dot end. Okay, now we are creating left and right pointers. Remember, what have we all prepared for this two pointer approach? We have created a nums with index array. Okay, we have saved all the values with its index as pair in the vector, and then we are sorting this vector. After sorting, Now we are initializing left pointer and the right pointer. Now while left is less than right, int sum equal to nums with index left dot first plus nums with index right dot first. Okay, it is using dot first because first part is always the values in this vector. Okay, that's why we are adding values. Okay, and if this sum is equal to target, okay, if it match with target, then result dot pushback nums with index of left dot second comma nums with index dot right, nums with index of right dot second. Okay, then we are pushing second parts of this left and right keys, because that second part is the index. Okay, so we are storing this indices in the result vector. Okay, after adding these indices in the result vector, left plus plus, right minus minus, else if sum is less than target, left plus plus, else sum is greater than target, which condition has, it's not needed to be mentioned, but I'm just clarifying it. That last else part we will just decrement right pointer by using right minus minus. Outside of this while loop, we'll return the result. Okay, so this way, we will just return the single pair. Okay, it will stop as soon as we will find the first pair. So I asked ChatGPT to modify it to add all the pairs. Now let's see how it handles duplicates and everything. Oh wait, return all pairs, modified approach. Great, it had given me two solutions and it has gone now. Great, before it has gone I wanted to record it but I missed it. Anyways, let's discuss this where whatever the answer is left now. What if we need to return all the pairs of indices? In that case, we have to handle all possible pairs. Okay, we can adapt the second code to some two pointers to collect all pairs of indices instead of stopping after finding one pair. Here is the step-by-step plan. Use nums with index vector to keep track of both values and original indices. Sort nums with index, and after finding a valid pair, that nums with index of left dot first plus nums with index of right dot first equal to target. Continue to look for additional pairs. Move both pointers to explore duplicate values and include all valid combination of indices. Okay, we have created a vector, we have sorted a vector, we have sorted that vector. Now we have created the pointers, left pointer, right pointer. Now while left is less than right, sum equal to nums with index of left dot first plus nums with index of right dot first. If sum equal to target, collect all combinations of indices for duplicates. Okay, now if sum equal to target, int l equal to left, r equal to right. Now we have created another two pointers, l and r. While l is less than r, ampersand nums with index l dot first equal to nums with index of left dot first ampersand nums with index of r dot first equal to nums with index of right dot first. Okay, l dot first equal to left dot first and equal to r and r dot first equal to right dot first. Then result dot pushback nums with index of l dot second comma nums with index of right dot second, l plus plus, r minus minus. Okay, collect all combinations. That means in these two pointers, for initially we created left and right pointers. Okay, Again inside that, if sum matches, then again we are creating L and R pointers, and for those pointers we have given this long condition where L is less than R, and L dot first equal to left dot first, and R dot first equal to right dot first. Okay, say I'm just reading it shortly to make you understand, but its real syntax is nums with index of L dot first. Every time nums with index array has to be mentioned, obviously. Result dot pushback, nums with index of L dot second, nums with index of R dot second. Okay, L plus plus R minus minus. Now outside this inner while loop, so that small L and R wala while loop, we have to again create a while loop to move these pointers. Left is less than right, ampersand nums with index left dot first equal to nums with index left plus 1 dot first. Okay, that means if we have duplicate values, then left plus plus, while left is less than right, right dot first equal to right minus 1 dot first, then right minus minus, left plus plus, right minus minus, and else if sum is less than target, left plus plus, else right minus minus. So my question to ChatGPT is, we are basically skipping duplicates here, right? We are only skipping duplicates here, right? I wanted to store that another possible solution as well. You understood it properly. We are only skipping duplicates after we find a valid pair. Why do we do this? Suppose you sorted list is this. If you just find one pair, 2, 4, then both 2's and 4's would individually give the same result. Without skipping, you might get duplicate results like this. Okay. Yeah, but we are not returning the values, right? Unique pairs allow multiple occurrences, don't skip. Yeah, but and we wanted to return the indices, right? Not skipping is a thing, and if there are duplicates but we are returning the indices, then we should consider duplicates as well. Duplicate values as well. Exactly, you got a very important point. Then let's be super clear. We are returning indices. Each number has unique index. Duplicate values must be considered separately. We should not skip duplicate values blindly because their indices are different, and it usually wants all possible index pairs. Exactly. If you had skipped duplicates, you would have missed some of these pairs. So general rules: return pair of values, no duplicate values allowed. Return pair of indices if values are same. I know, but where is the code? How to code this solution? Okay. Vector nums with index is created, it is sorted, classic left and right pointers created, their first values are added, compared with sum. If those are equal, L equal to left, R equal to right. N- I mean, when it is equal, we are directly creating L equal to left. I mean, L and R pointer. L is initialized with left, R is initialized with right. L is less than equal to R, ampersand nums with index of L dot first equal to nums with index of left dot first. Int temp R equal to R. Int temp R equal to R, while temp R is greater than or equal to L. Ampersand nums with index temp R dot first equal to nums with index of right dot first. Result dot pushback nums with index of L dot second, nums with index temp R dot second, temp R minus L plus plus. What are we doing? Multiple same values on both sides, collect all combinations. How is it collecting? While L is less than or equal to R, ampersand nums with index of L dot first equal to nums with index of left dot first. Then again temporary R pointer is created. It is initialized with R, while temporary R is greater than or equal to L. Nums with index of temp R dot first equal to right dot first. Then result dot pushback nums with index of L dot second, comma nums with index of temp R dot second, temp R minus. Okay, L, R and temp R, 3 pointers are incremented. I will just give this loop in the description, but it has angled brackets. Just remember this, okay? Take a screenshot to think on it. I guess it needs some time to digest this. Quick explanation: save value comma index pairs into a new vector, sort on values, two pointer approach, left comma right. If when sum matches, cross product of all left duplicates comma right duplicates, move pointers correctly. Bonus tip: you could have even optimized it slightly more by checking if left and right values are already same. Then formula for combinations applies, but our version is clear and safe for interviews. Show a hash map. Sure. Let's see this now. Awesome. Let's now build the hash map based version of all index pairs. Big O of n time, no sorting, handles duplicates naturally, super fast. Again, we don't need to handle duplicate, but it's okay. If we don't need to handle duplicates, we have one solution. But if we want to handle duplicates and even optimize it, then we will solve it by this method. After the result vector creation, declaration, we will create an unordered map, int comma vector of int num to indices, number to indices. Okay. We can add multiple indices in this in case of duplicates. That's good. Build a map value pointing to list of indices. For int I equal to 0, I is less than nums dot size, I plus plus num to indices, nums of I dot pushback I. Okay. For every nums of I dot pushback I. Remember this syntax: num to indices in square brackets, nums of I dot pushback I. Okay. Go through each number. For int I equal to 0, I is less than nums of size, I plus plus, int complement equal to target minus nums. Okay, we are calculating complement for every index, and then if the complement exists, if nums to indices dot count complement for int idx nums to indices of complement. If idx is greater than I, result dot pushback I comma idx. Make sure to not repeat or reverse. This idx is iterator in that list of particular value. That list of indices will be there for a value, right? So in that chotusa list, this idx iterator will move, and if it is greater than I, then result dot pushback I comma idx, pair of I comma idx. Outside of this loop, this if block, this for loop, this again if block, and this outer for loop, then we will return the result. Okay, so this is like big O of n, and this is also big O of n, big O of n plus n. I mean, this is big O of n for loop, this for loop is of big O of n, and big O of n plus n is equal to big O of 2n, which is basically big O of n. Mapping values to list of indices. We ensure idx is greater than I to avoid duplicates and self-pairing. Nice solution. Sorting big O of n log n, big O of n requires sorting big O of n, fastest and simple. Remember this hash map solution. Can you do it without extra space? Use two pointers with sorting. Because hash map uses extra space. Okay, hash map just use extra space. But it is showing big O of n for both. Sometimes interviewer asks optimize time as much as possible, then use hash map for big O of n time. Thank you so much for these bonus tips. Super mini dry run? No, thank you, we understood it. So yeah, I think here we can end our theoretical discussion on 2sum. Let's meet again when we code this solution on 2sum. But I'm planning to finish this medium section by discussing it theoretically first. We have just covered one problem in this, 13 more to go. Okay, bye for now.